Hey everyone, this is Abhishek Vishwakarma and welcome to my channel Coding Na Kariyo. Today I'm going to solve daily leet code problem. The problem number is 3190 and let's first read the problem statement. The problem statement is find find minimum operations. We need to find minimum operation to make all element divisible by 3. Say that you have a given any nums and these nums contain some values from where some values take from uh, like uh, include 1 to less than 50. In the constraint this is given, so suppose in the nums either we from 1 to any one of number from 1 to 50. It's like 12 1 12 and 6 and 9. Now the problem statement is find minimum number of operation. We need to find a minimum operation. When we find a minimum number of operation and when we do operation, when when an element is not divisible by 3 in nums, is this nums, like suppose we take first element from this nums, we'll check it. It is divisible by 3. No, it's not. If it means we need to perform some operations. We need to some perform operations. Now the description is you are given an integer array nums. Okay. In one operation here, I'm talking about the operations. In the operation, you can add it. Either you can add it or subtract. Either you can subtract from any element of the nums. When we perform this operation, when element is not divisible by 3. Okay. Now we take a second element from this nums is 12. 12 is divisible by 3. Yes. Now we move on a second element is 6. 6 is divisible by 3. Yes. Now we move in say, another last element of the nums is 9. Is this divisible by 3? Yes. It is divisible by 3. It means there is only one element. There is only one element which is not divisible by 3. So what we need to do, we just do some minimum operation. We do some operation, but minimum operation we need to make all element all element in the nums divisible by 3. Okay. Now sometime if you don't click the solution and approaches, so you just do one thing is uh, you just like find a pattern and find some observation and see the observation on input and output, so and write your observation in book and see what observation you take out from these observations, what output you take out from these observations. Now let's see uh, some observations. Now let us suppose that uh, nums contain any number of from one from where from including 1 to including 50. So let's take some few numbers from 0 to 15, and so now this number is present that it represent that this number is always divisible by 3. It means these all red circle elements are divisible by 3. These alls. Okay. Now let's suppose we take some example. We take example this first test case 1 2 3 4. Okay. Let's take example 1 2, 3, 4. And now first what we need to do, we just take one element of the nums. Is first element is 1. Is this divisible by 3? No, it's not divisible by 3. And you see that this nums position, this one position in this number from here to here. Now it is present here. Okay. And the next element is divisible by 3. No, it's not divisible by 3. Okay. Now you find out the position of these three element, this element here, and this element. And we need to find, we need to check this next element. Next element is 3. Is 3 is divisible by 3? Yes, it's divisible by 3. We just point it, but not perform any operations. We just first point it, then we talk about later what we need to do. And here we just find the positions. And 4 is divisible by 3? No, it's not. So here the position of 4 is here. And yeah, this is and these all 4 elements are present in the nums. So the observation is what? First we need to erase some unused things. It's okay. Later, wait a minute. Here 4. And so what we need to do, here we just see some observations. Okay, the first element, it is not divisible by 3. This element is not divisible by 3. It means we need to perform some operation on this element. And this is also not divisible by 3. We need to perform some operations. This element are divisible by 3, so we don't need to perform some operations. Here this is also this is also not divisible by 3. Okay, so we need to perform some operation. It means from these nums only 3 elements are divisible by 3. So we need to perform some operation from to 1 element or 2 element or 4 element. Now let's observe that we need to make this element, we need to update or alter this element which is divisible by what? Divisible by 3. So we need to perform operation, but the operation is either you plus it or either you subtract it. So let's suppose it, if we need to make this element which is divisible by 3, so either we make it 3 or either we make it 0 via this operation, plus operation or minus operation. Let's take two things. So this is 1. Either you make it 0, either you make it 3. These both numbers are valid because this is divisible by 3. So suppose how many operation you need to perform to make a 0? 1 element. You just subtract it and you can make it 0. And how many operation you need to perform to make a 3? 2 operation, because first we add it become 2, then again we add it become 3. So here we need to perform 2 operations. So but in the questions, so we need some element, those element which are divisible by 3. Okay, this is also valid and this is also valid. But what we need to do, we want only what? We want only minimum. We want only minimum number of operation. When we compare it, which operation are smaller? Which operation is minimum? This minimum or this minimum? It means this minimum. So we need to make this element 0. Okay, sorry, not mark it here. We need to make this element 0. And how many operation it will take it? One operation. Okay. Now let's take example 2. Let's take example 2. Not example, it is take a next element from nums. This is nums. Is 2. So same things we need to do here. Same things we need to do here. Same things we need to do here. 2. We need to alter these elements. So which those elements are divisible by 3. So either we make it 3 or either we make it 0. If you make 0, it will take 2 operation. If you make it 3, if you make 2 into 3, it will take, sorry, it will take only one operation. So which one is take minimum operation? This one. It means we need to make it, we need to make what? We need to make the element, those element, updated element is divisible by 3. So we uh, alter the element and make it 3, and this element is divisible by 3, and it will take how many operation? 1. This is take a minimum number of operations. So and now here we need to find, we also I missed to one thing is one is important thing is I talk about later. The first now we just talk about the element 4. Now element 4, this is not a divisible by 3. It means we need to make this element which is divisible by 3. So either we make this element 3 or either make this element 6. So we do same thing here. We take either 3. I just raise it. We want the next last element of the nums is 4, and this is not divisible by 3. We need to make 3. We need to change the element or update the element which are divisible by 3. Either you make it 3 or either you make it 6. If you make it 3, it will take one operation. Either you make it 4, it will take two operations. And the one more things, how do you know to which element make either this or either this? Like suppose here 4. How do you know, how do we know that either we convert into 3 or convert into a 4 into a 6? Now let's observe the thing is, now I erase everything. Now we erase everything. Yes. Yeah, I just talk about how do you know that if nums is not divisible by 3, so how do how I convert in which number? Here I know that I can convert from here to here. Okay. Either we convert 4 into 6 or either we convert 4 into 3. We also convert into 4 into 9. We also convert 4 into 12. We also convert 4 into 4 into 0. But only these two positions are minimum than this, then this, then this. Okay. And now also this one is minimum than entire. Okay, let's talk about how do we find it. How do we find it? How do we find, like suppose if this element we pick it, so how do we find 3 or how do we find 6? Let's suppose 4 divided by 3, it means that it means that these three these three the number is greater than these three. We know that it means 1 time 3 is greater than 4. It means 4 first come 3, then come 6 4, and we need to find another next element which are divisible by 3. So how do we find? We just what we do, we just add it. It's just like 1 into 3 plus 3, it will give you 6. So we get two positions in between. We get two nums, two element which are divisible by 3, and 4 is lies between these two element. And we need to find, either we need to make 3, or either we make it 6. First, also we need to find which is take a minimum operations. This one, we just find the distance. What? We just find the distance. Which one is minimum? Like 3 minus 4, take modulo, is give you 1, and 4 minus 6 modulo is give you 2. Which one is minimum? This one is minimum. It means we will convert 4 into 3 by doing operation subtract. When you subtract 4, it becomes 3, and this 3 is divisible by 3. Now this is our approach, and there is one more approach which is too simple. But why I am talking this approach, why I'm explaining this approach? Because for a logic building, and how do you observe the patterns. And now let's code for these approaches, and also we optimize to this code. Let's write a code. Now the n is dot length, and then we count operations. Take a variable which count the number of operation. We need to take, and we traverse in nums and pick one by one elements. Now after we check if it divisible by 3, okay, no need to perform any operation. If it is not divisible by 3, so we need to perform, and we need to find first, like suppose we need to find what? We need to find let's suppose in the nums 4 is present in the nums, and which is not divisible by 3, and let's find out their positions, their those number which is divisible by 3, sorry, which is divisible by 3. We find left and we find right. Okay, we find right and we find for left. Now we observe that now this value, this which is divisible by 3, your 4 is now lies in between these divisible by 3 nums. Okay, and we just find what? We just find minimum distance. The minimum distance is your answer. Minimum distance means minimum operation. You need to make the non-divisible element to the divisible by 3. Okay, the first divisible element is like what? Value divided by 3 and value divided by 3. Value divided by 3 give you 1. This, like suppose nums is 4, sorry, value is 4, and this divided by 3, you get you 1, and we need to multiply by 3, because now we need to for better understanding, we takes another nums value. Like suppose if value is 10, suppose if value is 10, now when we, now the value is 10, we divide by 3 and we find left divisible. Now we divide 10 by 3, it give you 3. If we give you 3 and you just multiply by 3, this fixed value and this value come from this, and when you multiply, you get left 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 what left divisible, left element, which is divisible by 3, and we need to find next this element. Next, not next means we need to find right element which are divisible by 3. Just right. The next element which are divisible by 3 is 12. So how do we calculate? Just you add 3, you give you a next element which are divisible by 3. So we do same here. There we find left divisible and right divisible. Now here by these things we get left divisible, and if we want to just next element which is a divisible by 3, just you add it 3. Okay, and we find minimum operations, means minimum distance. If the value is minimum from this side or this side, it means that we need to find, like suppose is 10, 10 is closest to 9 or closest to 12. How do we find? Via distance. We find the distance. Which one is take which one have less minimum distance 1. It means we need to make this 9, which because it will take a minimum number of operations. Also we need to make, also we can make 12, 10 to 12, but it will take 2 operations, so it's not a minimum. 1 is minimum. Okay, and now we need to find minimum number of operations. It means math dot minimum left minus divisible left divisible by value, and also it will give you negative, so I will take a mod of those distance. It means like how do we find? We just 10 minus 9, it will give 1, this one. Okay, we get the distance, and from, and if we need to find this distance, you just, what we do, you just minus 10 minus 12, it will give you 2 minus 2, but I will take mod. Now math dot apps left divisible element minus value. Now after this we add into a count operation, minimum operations. Okay, and just we return this minimum operations. Now when you run it, Sorry, spelling mistake. Now again we run. Now successfully run. Now we submit that. Now we run it. Now the optimization is not good because we do some this operation, and also there is one more operation is one more approach which is more optimized. The again we need to observe things is what we need to observe one more things what if suppose take one element which is not divisible by 3 like 4. So 4 if you make 3 or if you make 6 which is because this those are nearest to the is nearest which nearest to those elements which are divisible by 3. Either you make it either you convert 4 into 3 or either you convert 4 to 6, but always we take a minimum, always take minimum, and minimum take only one operation, minimum take only one operation. Either we suppose 8 is not divisible by 3 and we need to make the 8 those number which are divisible by 3 we need to update either in 9 or either in 6. We always take minimum operations. Okay, so always minimum operation it will take 1. My explanation is and question is if you get those if you get any element which is not divisible by 3 you just count it, because any element which are not divisible by 3 place it anywhere, like here. Now here we need to make this element either this or either this, but we need to take only minimum operation. Only minimum operation it will take 1. To minimum operation we perform only one. Only one. It means we don't need to process these things. We just add it. We just what we do? We just count it, and now we run again. We successfully run these two case. How we run? Because now let's take this example. This element is divisible by 3. No, count it. Now this cut it and become 1. This is divisible by 3. No, it's not. Now again we update the count operations, become 2. This is divisible by 3. Yes, it's divisible by 3. Don't change your count operation. This is divisible by 3. No, it's not. You just update it. The final output is 3. The test case final output is this. It's same. Okay. Now this is optimized approach. When we submit it, let's see. Yes, this is 0 ms runtime and beast 100%. This is optimized. And thank you guys to watching this video, and I hope you get a good for you for logic building and also for institutions. And now please like and subscribe this video, and please comment on below this video. Okay, now thank you guys. Bye bye.